2A, Unit 2, exponential functions. What is today? Today's Jan 20, Jan 20. All right, let's start marking some stuff. Can I move you? What can I do to move you? Did I do it? No. What if I just hit you? No. How about you? Yeah. All right, let's see what's on here. Let's just start it out, see if we can get a feel for it. Hey, what's happening between each x? I think it's supposed to be like an and symbol, not the plus, because it made me think like it's addition. Change your plus to and. What's happening between each x and a y value? Is there a pattern here? Let's see. Can you write an equation? Ooh, shoot. Now that part's going to show up a bunch. Now hopefully I can teach you how to write an equation, because they're going to ask you to do it at least 3 times, and it's going to matter. Can you write an equation for this? Yeah, is it a positive, negative, increasing or decreasing, a linear function or exponential function? Okay, that's a lot of questions. Here's what I would ask you to do in English. Figure out what the pattern is. Oh, wait a second, they jump a little bit. Let me put the little, they jump a little bit. Make these marks on yours if you could. Then they jump again. Someone try to figure out the pattern somewhere around here. Try and write down what you think the pattern is. Like, yeah, okay, all right, but don't say anything out loud yet. Don't say anything out loud yet. Something's happening with it. What's the relationship between these numbers over here, these numbers over here? Something's happening. Try and write it down. I know some of you will be able to see it, like, oh, I see it. But if you have to, like, but I don't know how to say it. I know what's going on. I don't know how to say it. See if you can write something down. Let's pause it. I'll give you like a minute or so. So we got to multiply by 7 as part of the pattern. What's going on here? Over here, do we have an equation, anybody in this group, to represent your whole side? Oh, let me start you off. Sorry. Let me start you off with a y equals something. Now I'm going to go back to Tina in just a moment, but let me give this side a chance. I wouldn't want one person to beat up a whole side. I wouldn't want that. All right, let's find out what you got. What you got? You got something, Tina?
Y equals x times 7.
X times 7. That is when I put in a 2 here, it gives me a 14. Okay. When I put in a 3 here, it gives me 21. Okay. Boom. There's the formula. Now, some of you probably felt that. You just know how to write it. You knew some had to do with 7 in there. And so it's true. Now if I need to, let's find this out. Let's say now that we have a formula, write down the answer, the partner, for when x is 100. See, before that, the 100, we might not have known the partner, but put in the number for when x is 100. Who's the partner? I know the partner for x is 2. The partner for x is 3. And a little hint for those who want a little bit of hint. I know the partner for when x is 10. Write down something, even if you have to guess. Hopefully you're next to someone who's super smart, because I'm okay with you peeking on people. So I'm like, no way. I always think the same thing. All right. Just, if you're not sure, I'm okay with you looking on the neighbor. I mean, not on the test, but here. What's that number? What's the partner? Say it again. 700. And so the pattern goes on. Does anyone know if this is a linear? I would just add 7 and get here. Now, of course, it clipped out the middle piece. But if the 4 was in here, the partner of the 4 would be 28. And again, to get from the 21 to the 28, you would add 7. The moment you're adding the same number, then is what we call a linear function. Also called, what's the other guy? So another word, arithmetic. Arithmetic function. Okay. So we got some names. We're checking this thing. We're adding. If we have to multiply to get to the next one, here's something. But you are multiplying. You're multiplying times 7. Let's see how I write that if I was trying to multiply it. Well, this one is 7 times 7 times 7. Yeah, the problem is these numbers are changing. No. I guess we can't use these. You can't use these over here. It's only these that you use. Either you're going to put plus 7, or you're going to put times 7 times 7. So I did times 7 times 7. I'd be doing 7 times 14, 7 times 21 to get to the next number, but
So it only relies on the y values.
right, yeah. So yeah, over here I can see now, oh, 7, 7, 7 gets you that, but when it's time to check what type of thing it is, you can only use this line here and produce a number of your own. All right, let's keep moving. Let's see what it, but that number that's standing in front of that variable, he has a special name. Numeral, it is a numeral, but he said even if he's not standing in front of that letter. If he's standing in front of that letter, his name now begins with a C. Put the second letter in a second.
Coefficient.
Yeah, coefficient. Coefficient. Please write it out. Coefficient. That one I need to look up and find out why it's called that. Coefficient. But again, as some of you may know, math, you barely need to know why anything does whatever. You just need to remember it. You have a good memory, you can be good in math. The bad part about it is, who cares? Who cares? And for those who don't know, if you don't care about something, it's really hard to remember. If you care about it, oh yeah, it's easy to remember. Make a table with this. Like, what the heck? Come on, make a table. Let's see if I can make a table. Don't use my numbers though. Use your own numbers. All right, here we go. Make a table. Make an XY table. Now I'm gonna use famous numbers. No, let me not use famous. Let me use something that's unfamous. That way they can use the famous numbers. Shoot. I'm gonna use a negative number, and I'm gonna use a positive number. Okay, you can use one of mine because there's not that many up there. Excuse me to use. So I'm gonna use -1, and I'm gonna use +1. There's one that I didn't use. That's a famous one that I was gonna use. With all math people, we start with a number in between these two that I won't say the name. Make your own table. Let's see. When x is 1, when x is 1. Y is going to be 7, because 1 times 7 is 7, for those who don't know how to build a table. Dang it. 1 and 7, when x is a -1, I'll put you in red. Y is a, what are you? You're a -7. So on my graph, I'm going to put in those two dots to see if it actually match up with what they have. You make yours. You can use one of my partners, but you need another partner with a famous number that's between -1 and 1. Let's see, 1 and 7. 1, 2, 3, 4, 5, 6, 7, right? Which should be on the dot, even though my little clicker thing is a little bit off. And 1 and -7. Sorry. Let's make you green. And your partner down there, -1 and 7. Let's see, 1, 2, 3, 4, 5, 6. Uh-oh. 7. Am I counting right? 1, 2, 3, 4, 5, 6, 7. I'll make it wide enough like you were on the dot, which you should be. I'm gonna put in my coordinates. -1, comma, -7. I'm gonna put in up here. You do the same thing that I'm doing, and then you should have a third dot. The third dot is that extra point on the table that I didn't write. It's a famous one. It's the number between -1 and 1.
What if you graph that number?
Yeah, I want you to. That way you'll have 3 dots on yours. Put in the coordinates if you know it. If you don't know it, look on somebody else's paper. The new type of star. Find out the pattern on this problem. All right, I got times 3, and then to go down to the next guy. All right. Is this guy, please write down, is he arithmetic or is he geometric, which is linear versus, what's the other guy, expo. Write that down, but choose one of them. But don't say it out loud. I want somebody to guess first. The writing equation, hopefully Tina got it this time. Let's see what happens. All right, David, yeah. Yes. David may have the equation this time. All right, so first out loud, hold, don't get the answer, use as a backup on the arithmetic geometric. Someone, arithmetic geometric? Yeah, Geo, how do you know? Right. All right, we got that part. That one wins. You're a loser. All right, the second question, you got an equation?
I don't know how you would write it, but then it starts going times 9 and then times 8. That's quite big.
No, yeah, you are right. The pattern does say we're multiplying by 3. The hard part, which is what this new unit is about, how do you write that. There's a way to say, so I know what happens on number, this is going to be a big number because these are getting big really fast, so I'm going to go to 10. We're skipping the in-between where you keep multiplying, multiplying, multiplying. There should be a way that there's an equation, I can just plug it in and boom, comes out. All right, somebody help me.
So it's possible to put y1 times 3 equals y2.
Y1 times 3 equals Y2. So when Y1 is 3, Y1 is...
That's x.
Yeah, sort of. You're... Alright, I'm going to say something about why they're the same, and they just have different names, which is cool, because all it really is a name. You chose Y1. A math person would have chosen X, which is fine. We just see what if it does a thing. When that Y1 is a 3,
What do you mean? Why are you going to the x?
we want this is the equation for this thing here, yes?
Yeah, for that part.
So if I put a 1 in the place of this, it'll be 1 times 3 is 3, right? And also, if I put a 2, 2 times 3 is a 6. If I put a 3, 3 times 3 is a 9. If I put a 4, 4 times 3 is a 12. That's how I would use it. Somehow this thing here has to produce these numbers.
Also, it has to be x and y though.
It doesn't have to be X and Y. Whatever letters you use, the equation has to produce these numbers though. So I can see where you can get a 3. If I put a 1 here, I get a 3. If I'm happy. If I put in a 3, I can get a 9, because I need to get this 9 somehow. How do I get the 27? Well, if I put in a 9.
Well, no, I'm saying like y1 times 3. So the first y is 3. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3.
Got it. Okay. Y equals 3 to the x power. Now, how does this do the thing that we want? Here's the way it works. If I raise 3 to the first power, 3 to the first power is just 3. So people know that. Some people are good at math, so they're like, really? Is that true? Yeah, it's true. Anybody know what 3 raised to the second power equals? Yeah, 3 to the second power equals 9. And if you didn't know it, I'll ask it though. Anybody know what 3 to the third power equals? 27, and so on. In other words, the more exponents, the more of these guys you do, let me see if they can see it. 3, 2, 3, 3, 3, 4, so they can see it. Let's put out the number of 3s we have. We got 2 of them. We got 1, 3, 3, 2, 3. The exponent tells you how many times the base can be written as a factor, and you have 4 on this one. All right. So let's see if they can see this a little bit. 3 times 3 is 9. 9 now represents these 2 3s. 9 times 3 is 27. The 27 now represents these 3 3s here. Adding 1 more 3. In other words, to go from one row to the next, when you write it with exponents, it's as if you were multiplying 3 times the next guy in line. It's a bad way to say it, but now let me say it again for those like, look, I don't know what you're saying. What do you want me to remember? Because I want you to remember. To write an equation for an exponential sequence, it's always going to be y equals the number, also called the common ratio. Y equals the number that keeps showing up, raised to the x power. So if this was like times 4, times 4, times 4, it'd be y equals 4 raised to some power. If it was times 5 times 5, y equals 5 raised to some power. Now, for some of you, your life is complete. You now know an exponential function. Why is he teaching this? The point 0, 1. So here's some good news. Let's say you're not a genius, but they ask you to graph an exponential function. The dot 0, 1 is your friend. This allows you to look smart when you are not. Say, please graph the exponential function. Y equals anything. Anything, we'll call it the letter B. Raised to an x power. No matter what that b is, it's a 7, it's a 25, it's a 37, we don't care. It has to go through the point 0, comma 1. There's a reason for it. I could say it now for the two people who would get it. I'll say it eventually because we need to know where this comes from. The other parts of the picture, they come from a table. What table is he talking about? Same table, XY table. This time you can just write down what I have. Famous XY tables, generally you go ahead and start with a 0, you do a 1. If you want a third dot, put down a 2. This is going to be smarter than your parents at home. Like, hey, I'm graphing an exponential function, Mom. But first I'm going to start with 0, 1, and 2. Why did you do that? Because I'm smart. If you have that kind of relationship with your mom. Don't get slapped. Oh, whoa. Because some of you all, maybe there's not that kind of violence in your home, so don't get put on timeout, whatever your situation is. Don't get grounded. In any case, let me do 1 and 2, then there's 0, 1, and for some of you, we're like, oh, that's fine. Others will go like, okay, I don't get it. You get it? Well, some of you, the light will come on, you feel good about yourself. Here we go. Anybody know what 3 raised to the 1 power is? 3? Yeah, he's your friend. The 1 is always there because he's always the easiest thing, so he's a 3. How about 3 to the 2nd power? Say that again?
9.
Yeah, 9, no big deal. 9, no big deal. Let's back up to this weird one to find out who is quote-unquote smart or who remembers. That's what smart means in my classroom. Smart means I remember this. I heard it before, I still remember it, so that when teacher asks me the question, I know the answer, boom, that means I'm smart. I don't remember it, I can't give you the answer. Technically that means I'm dumb, but we know it just means I don't remember it. So here it comes. 3 raised to the 0 power is... Dang it. What class is it? Oh, this is 2A? They had to see it in algebra, which I get it. It's like a whole year, and at options a year and a half ago. We get it. Maybe 2 years for some of you. No, not that. Don't bet if that's not the family you belong to. Here we go. 1, 3. Teacher told me to. No, I didn't tell you to. Yeah, that's your own life decision. All right, here we go. 1, 3. 1, 2, 3. And 2, 9. 2, 9, 2. Now, exponential functions, we don't do a lot of table because it increases so big and so fast that the next one after this would be like, what, 27? And that's going to be too high up, so we'll just do usually 0, 1, 2, and that's enough to put in points. Where are you? 9, 1, 2, 3, 4, 5, 6, 7, 8. Write down your coordinates next to it. That way you can show somebody, look, I didn't just make this up. Coordinates. All right, pause, take a look. When we graph this equation, it is curved like a hockey stick. Therefore, in math, we get to use the word therefore, and it's also represented by 3 dots, also like the Vita look on your wrist, on your little thing here. Yeah, not that. Therefore, it is an exponential function. Hockey stick equals exponential function. This is a common ratio pattern happening. Got it. Pause it. Problem. Let me find one more real one. Put a question mark on that one. If you know how to do it, try it at some point. But let me just see if I can find one more real one. Frogs.
A frog, really?
All right, let me do this one. Dang it, you see what I'm saying? As a matter of fact, I'm not going to do this problem. I'm going to take my 2 minutes to just talk about it. Not about the math problem, about the frog. Because the frog is more